In this example, example number 2 on page 165, read the question. It says, Alexa has a small gardening business in Victoria and she planted 14 daffodil bulbs in a client's garden in the fall. In the spring, 12 bulbs flowered. So the total number of bulbs, daffodils, total number of daffodil bulbs is 14. And how many of them flowered? Number flowered? 12. That means how many did not flower? Yes. That is 14 minus 12. That's 2. Out of total 14, 12 of them flowered and 2 did not flower. Right? Now read the question A. Based on these statistics, what are the odds in favor of a bulb Alexa planted in another garden flowering? Based on this data, what are the odds in favor of a bulb flowering? How would you write these odds? You know that the event is a bulb flowering. That's the event, right? And when we write the odds, the first number that we write is in favor of that. The second number that we write is against it. How many bulbs flowered? 12. So that would be 12. Sorry?
So we have to write 12.
12, yes. Because 12 of them flowered. And how many did not flower?
2.
2. So this is the number in favor of this event, bulb flowering. And the other number is against it. The bulbs, number of bulbs that did not flower. This is 12 to 2. This is the odds in favor of a bulb flowering, right? Out of 14 chances, there is 12 times that the bulb will flower and 2 times the bulb won't flower. This is in favor of flowering. But you need to write this in the simplest terms. You can divide both of them by 2. That's a common factor. So this will change into 6 to 1. So that's your answer. The odds in favor of a bulb flowering is 6 to 1. Right? If you add this 12 plus 2, that should give you the total number of events, 14. And you can write this number as 6 to 1 also. There are 2 different ways to write your answer. 6 dot dot 1 or 6 to 1. This was part A. Now part B of the same question. Read the question. It says, what's the experimental probability that a planted bulb will flower? Here we found the odds in favor of a bulb flowering. Now you have to find the probability, the experimental probability of a bulb flowering. So basically we are doing the same thing. Whatever we did here, the odds in favor of a bulb flowering, we are doing the same event. The event is still a bulb flowering. But the difference is that here we found the odds in favor of a bulb flowering. Now we are finding the probability of a bulb flowering. Right? And how do you write the symbol? You write P for probability, and in the bracket you write the name of the event. You can say probability of a bulb flowering. How do you find the probability? What number goes at the top? The number of events, the bulb flowering, how many times it flowered?
14.
12, yes. And divided by the total number, that was 14.
14. Or 6 to 7.
Yeah, and then you divide them by a common factor. You know that you can divide this by 2, you can divide this by 2. So this will give you,
6, 7 divided.
this is the probability. How do you write it in words?
6 out of 7.
6 out of 7. You don't write it as 6 to 7. It's 6 out of 7. And if you divide them, what's the decimal number? 0.86. 0.86, which is equal to 86%. So there is 86% probability that a bulb that you planted will flower, right? And the odds in favor of a bulb flowering is 6 to 1. Again, the only difference between the odds and the probability is the number that we write here. This is against number and this is the total number. That's the only difference between the probability and the odds. Any questions? No? Okay. Let's do one more question on the next page. This one is on page number 166 and it's question number 4. Build your skills problem, question 4. Read the question. It says a grocery store is running a promotion. Everyone who makes a purchase receives a ticket that may win them a prize. And what are the prizes? It's given that 5,000 tickets, say, they printed 5,000 tickets, and 5,000 tickets, they say, please play a game. They also printed 125 tickets, and these tickets say save 5% on your next purchase. And then they printed 5 more tickets. These tickets say save 50% on your next purchase. Save 50% on your next purchase. So that means how many tickets they printed? The number of tickets printed. How many? You'll add them up? Yeah. 5,000 plus 125 plus 5 is equal to 5,130 tickets. This is the total number of tickets they printed. And out of them, 5,000 say please play a game. 125 tickets say save 5% on your next purchase, and 5 tickets say save 50% on your next purchase. Now the first question is, question A, what are the odds in favor of getting a ticket offering 50% off? Let's say you go to that store and they give you a ticket. What are the odds in favor of you getting a ticket out of these 5? The odds in favor of getting a ticket that says 50% on your next purchase.
5 to 5,125.
Yes, yeah. So this is our event. The event is save 50% on your next purchase. So the odds in favor of getting a ticket that says 50% on your next purchase, whatever. Getting a ticket out of these 5 is, how many tickets are there? 5 tickets. So this is in favor, and what's against it? How many tickets don't say this? How many tickets don't say 50%?
5,000.
5,000 plus 125. Because just 5 tickets say 50%, and both of these types, they don't say 50%. That's against your event. This is in favor of your event. This is against. So the sum of the other two types, 5,000 plus 125. So this will be 5,125. And make sure any question that you do in the odds type of problem, their sum should be equal to the total. So if you add 5 and this, it will give you 5,130. But now you have to simplify this. If there is a common factor, you can divide them. You can divide both of them by 5. 5 is a common factor. When you do so, what do you get? 5 divided by 5 is a 1. And 5,125, when you divide this by 5, you will get 1 and 0 and 2 and 5. 1,025. So the odds in favor of getting a ticket that says 50% off is 1 to 1,025. Right? Are you getting it? Okay, look at next one, B. What's the probability in favor of getting a ticket offering 50% off? Well, I mistakenly erased that. We had total number of tickets. How much was that?
5,000.
5,130.
30.
And the tickets that say play a game, number of tickets that say play a game were 5,000. And number of tickets that say 5% off was 125, and the number of tickets that say 50% off was 5. So this way the total number of tickets were the sum of these three, that was 5,130. Okay, now the next question is, what's the probability of getting a ticket that says 50% off? The probability of getting a ticket that says 50% off. How many tickets are there that say 50% off?
5.
5. And how many total number of tickets are there? 5,130. Because its probability, the bottom number will be the total number of events. And you can simplify this. 5 is a common factor. You can divide both of them by 5. This will give you 1 over 6. So it's 1 out of 1,026. You can also change it into decimal number, divide them. What do you get? 1 divided by 1,026.
0.00097. 74.
0009?
74.
74. And what will be this in percent? You multiply this by 100, that will be
0.097%.
yes. It's a very, very small probability. There are very, very thin chances of winning a ticket like that. That's what these grocery stores do. But you still go there. probably I will win. Right? There are only these many chances of winning. Okay, the next one, C, says what are the odds in favor of getting a please play again ticket? Odds in favor of a ticket that says please play again. Odds in favor of a ticket that says please play again. So you're finding the odds now. How many tickets are there that says please play again? 5,000? 5,000. This is in favor of this event. And how many tickets are against it? Against means those tickets that are not like this. Sum of these two, 125 and 5. 125, those tickets that say 5% off, and 5 tickets that say 50% off. So this is 5,000 to 130. The odds in favor of getting a ticket that says play again is 5,000 to 130. And you can divide both of them by 10 because 10 is a common factor. When you do so, you get 500 to 13. Or you can write it as 500 to 13. These are the odds in favor of getting a ticket that says please play again. 5,000 to 13. Now I want you to try the next question, number 5 and number 6 on your own. Try it.